Tips for teaching 3D printing, straight from the 3D printing enthusiasts. Next on the K-12 Engineering Education Podcast. I'm Pius Wong, engineer in Austin, Texas. My guests are David Seto and Michael Welch. Between the two of them, David and Michael taught 3D printing to kids in Hong Kong and elsewhere, and they turned their experiences into a set of guidebooks for teachers and hobbyists titled The 3D Printing Cookbook. We had a call recently to talk about it. Hey, welcome to the K-12 Engineering Education Podcast, David Seto and Michael Welch. And you're both authors of the 3D Printing Cookbook.
That's right.
Give me a brief background, I guess, or brief introduction of who each of you are and where you are, actually, because I know we're speaking in different locations. David, maybe you can go first.
Okay, thank you, Pius. First of all, thank you for inviting us to be here. We really appreciate this. I'm probably not your typical interview in the sense that I'm not a STEM teacher in the traditional sense at all. I'm not a teacher at all. I come from a very far away background. I'm actually in Hong Kong right now. And I ended up in Hong Kong by way of New York City, where I grew up, and where I got an MBA in finance, and I worked on Wall Street as an analyst. And then I spent almost 10 years in Hong Kong, here in Hong Kong as a banker for a big bank, also as a financial analyst. And then it was another 7-8 years in Beijing, where I was the CFO for a small company. And so when my daughter was born, something amazing happened. And actually, all of this happened while it was in Beijing. Number one, I met Michael Welch, the co-author. And also at that same time, it was like it was 2003 or 4 or something like that. So as a banker, we would read The Economist magazine. So there was one issue of The Economist magazine that had a photograph of a violin. And the caption at the bottom says, "This is a 3D printed Stradivarius violin, and it plays beautifully." So that was, for me, that was my light bulb moment. And I thought, wow, what is this technology that can produce a Stradivarius violin? It was amazing. So at the time, I was Michael, and I asked Michael, what is this 3D printing stuff? And he goes, yeah, that's like super cool stuff. It's like, imagine a 3D printer that can 3D print another 3D printer.
Yeah.
And that was another light bulb moment for me. And I thought, whoa, what is this going on? So at the time I was the CFO for a company. But I started researching this. I mean, the Economist magazine article was the first, and then there was this explosion in 3D printing conferences, which I attended. And so it just got me, one step led to another, and I started getting more into the CAD, the 3D printing software that creates 3D models for 3D printing. And so I just hacked myself. I just learned the software as much as I can. I learned I learned several software, which ultimately, told me, goes, okay, after I leave finance, I'm definitely going to try 3D printing, teaching 3D printing. So that's sort of like how I got involved in 3D printing.
Wow. So self-taught in 3D printing from nearly 20 years ago.
Like 10 years ago.
10 years ago? Okay. And it sounds like Michael already knew about 3D printing at the time as well. Michael, do you mind talking about your background too?
Yeah. So my background is kind of in design and technology. So I used to run a mobile games company in China. And so at a lot of conferences, we'd see like 3D printed avatars and things like this. And so we got kind of exposed to it a little bit early. And I always thought it was interesting. I wasn't sure where it was going or how fast it was going. And David came and asked me about it, like he said. And, I thought, it's actually pretty cool and has really great long-term potential, I think. And I didn't think much of it after that. And then Dave started doing all this stuff with 3D printing. And then after a while, I got a little bit bored of games and kind of wanted to do something more, without in-app purchases in it. So I started looking at education as kind of a good application of gaming stuff. And Dave was involved in teaching 3D printing in schools, and I just kind of talked to him about it and got involved. And I actually did some classes here in the States with elementary school kids third and fourth graders. And it was just amazing. It was like really, it was much easier than I thought. I mean, I was kind of following the recipes and everything, but just the stuff they would do, like, you couldn't imagine. Like this one kid, he was making a ring, and he put a battery on it, like a AA battery, because he thought it was cool. Very uber geek guy. But anyway, so I just got interested in it with Dave after he kind of started doing this education, young kids, 3D printing classes, and I thought it was something worth doing.
That's awesome.
Yeah.
And so I know David said he's in Hong Kong right now. Y'all met in Beijing. We should say, Michael, that you're in the States right now too, right?
Yeah, that's right. I'm in Seattle. Yeah, just outside of Seattle.
Got it. And it sounds like you both are self-taught in this tech field, which is pretty awesome. I actually think that's really similar to a lot of the teachers who might be listening. There's a ton of teachers who have to teach engineering and they never had an engineering background. So I'm curious, I know you summarized it really quickly, both of you, right? But were there any challenges along the way in learning how to use the software, how the technology worked, the costs of it all? Like, what was complicated about picking that skill up?
Oh, that's a very good question.
Yeah, David, you can start. Yeah.
Yeah. So when I first started learning the software myself, I mean, YouTube is your friend. I mean, you just go to YouTube and go through the videos. Now it takes time. Now, as it turns out that I'm in a lucky position, and because of my work in the past, I was able to sort of have some savings available so that I can actually take some time off to hack through the software. I mean, literally hacking through the software. Now, when I speak to other teachers, when I teach at a school, there are full-time STEM teachers there. And I show them what I do, and they go, man, David, that takes time. There's like no way I can go through all that material. I mean, you have the time. I don't have time. And that's actually a reality, I believe, of STEM teachers there. They're just so crunched on time, which is why we thought, okay, I needed to do a couple of things. So number one, make this skill transfer of learning the CAD as smooth as possible. And one of the best ways of doing that is to make it a good reference, to have a good point of reference, right? And that's why we chose the theme of the cookbook, right? Because everybody knows what a cookbook is. So there are direct parallels between using CAD to create a 3D model and making, for example, chocolate chip cookies, right? When you open up the software, of course, it's very intimidating. You know what to do. But if I tell you, look, these are the mouse clicks, these are the tools you need in the CAD software, right? And those are your ingredients. And then you follow these steps, and mouse click by mouse click, you will mix and match these ingredients in this particular way. And in the end, you will get your model. Okay. And that's why this cookbook is set up the way it is, right? There's a photo of the final product, like, just like in a cookbook. There are a list of the ingredients, the list of the tools, and then there are the steps to make the model. And then there's like 10, anywhere from 10 to 15 steps. We've designed it so that these models can be done in about 3 minutes. So as a teacher, if you're teaching this, right, if you know the mouse clicks, you should be able to make every one of these models in about around 3 to 4 minutes. And that's how I teach. So before a class session, right, I will have, okay, today I'll cover, for example, the table. As well as the cup, right? So I'll just quickly make sure that the Tinkercad or the Fusion 360 is working properly, and so I will open it up and then I'll just run it through myself. And usually, at this point, I've memorized all the steps and I just recreate it. I just know how to do it. So when I go to the class, I can just say, okay, follow me, everyone. So mouse click will follow me. So and that's generally how I run the class. Now, the ultimate goal of the book is not for the students to learn how to do that table or to do that cup, okay? I want them to take those skills, the ingredients from those models, apply to their own models.
Sure.
Right? In fact, pretty much every model that I teach, I say at the end, I say, okay, table's done. Now delete it and do it again, right? The cup is done. Delete it and do it again, okay? Because the more familiar they are with the ingredients, with the mouse clicks, the faster they can use it to make their own bottles. And that's really, really my ultimate goal.
So your new book, the 3D Printing Cookbook, it seems like you are trying to simplify all of this stuff. I guess we should mention that you have been teaching in person, and that's what your book is based off of, right?
Yes,
your
correct.
Own teaching. Okay.
Yeah. So actually, this is Michael and mine COVID project. Before COVID, I mean, I was able to teach about 500 students here in Hong Kong in multiple after school classes in several schools here in Hong Kong. And I just loved it. It also turns out that Michael and I both have children of similar age around, my daughter's around 10. Michael's is about the same. Yeah. So when I teach at my daughter's school, it's just fun to see her once in a while. And then we come home and we can talk about what happened in class. In fact, my daughter likes it so much, she actually joins the class, and I'm sort of training her to be an assistant as well.
Then you got to pay her, I guess.
More or less, yeah.
And so, Michael, since you're not in Hong Kong, had you been teaching? You said you taught a little bit in the States. Were you also teaching with the same kind of curriculum?
Yeah, so I was using the same kind of curriculum that Dave had. So it's basically the same recipes that are in the book. And I think one of the key things is, like, while it's 3 minutes to 5 minutes for for you to do it as a teacher, it might take the kids like 10, 15 minutes, as you're managing a class full of kids to kind of go through all the recipes. So that's why, the tools are kept the models are kept pretty simple. And then also the kind of different tools you use are kind of spread out among all the different models. So it's like you really get a little bit of this, and then you do another model, you get a little bit of that, and then you can kind of start to blend them together. So yeah, I just think teaching was wonderful. I mean, it's just I actually went in with another STEM teacher that was there, and I just kind of did her STEM class for 3D printing. So she had other stuff, and so I just came in and did the 3D printing part, and that was really cool because they had a mothballed 3D printer in the school. I think a lot of schools bought them, but it was sitting in the library underneath some kind of reams of paper.
Oh no.
Yeah. So we were able to get it out and get it started and get it printing. So I thought that was pretty cool. And then later I kind of trained her on kind of how to keep moving it forward. That was cool.
That's a good point. I've heard this discussion or that point made by other people about technology in schools, that it just kind of might collect dust if there's no expertise or confidence about it. So that's great that you have this resource here that hopefully can spread the knowledge more. You already started talking about the book, but let's get into the details, I guess. If you had to summarize the purpose of the 3D Printing Cookbook, what would you say it is? Is there like a mission or a one-line purpose of it?
Yes, for me, it's to save time. It really is to say. I know because I only teach after school, and I run into teachers all the time, and they're always busy. I admire them so much. It's like, man, these guys are so busy. And when I learned this CAD software, it just took so much time. So the whole point of this book is to save teachers time. And then, one of the side benefits is that if the teachers go through the lessons with the students will learn the software well enough so that they can create their own models. So it's a massive time saver. And please note, it's actually 2 books. So Michael and I delivered twin. We didn't do one book. It was twins. Okay. There's one book, the 3D Printing Cookbook, Tinkercad edition. And this is designed for students age 8 to 11, right? These are the primary school kids. And then there's the 3D Printing Cookbook Fusion 360 edition. And this is for students age 11 and higher.
And so what would you say the difference is between Tinkercad and Fusion 360 for any teachers who haven't used CAD or they haven't done 3D printing yet?
Tinkercad is really child-friendly. It's very colorful. There's a lot of pre-made shapes already done for you. So that's Tinkercad. It's really for younger, total beginners. Okay. And when you see an 8-year-old working with it, it's actually kind of fun. I'm jealous of them. In fact, I wish I was an 8-year-old.
Yeah, I would add Tinkercad is kind of like Legos or Minecraft. I think it's super easy and super approachable.
Right.
Would you give that for older Tinkercad to any older students, college students, or is that too juvenile?
Actually, that's an interesting question, Pipe, because I also teach adults. And then I gauge the level of interest for the adults, and if I find they're sort of like they're not really tech savvy, I will teach Tinkercad. Yes, but tech savvy people, I will teach Fusion 360.
Yeah, I think even for tech savvy people, sometimes they will fall back to Tinkercad just because they know the tools available can make it really fast.
Yes.
And if they know they're not going to need the advanced features of Fusion 360. They'll just go ahead and do it in Tinkercad because it's so easy.
Yeah, it also depends on the model. Yeah, sometimes I need to do something really fast, and I will just use Tinkercad. But Fusion 360 is it's industrial use. I mean, it's actually used in industry right now. Autodesk has a policy where they all their software is free for education use. So you can when you apply for an account, you just tell them which school you're at, and if your email has a .edu at the end, they usually grant you access.
Yeah, I'm glad you mentioned that, David, because the big hot topic, of course, today is access to STEM education or access to all these things. And of course, if people think Fusion 360 is like this super expensive thing, that's not going to help with access. But so something else I was wondering was then, would you say that your guidebooks or your books are mainly for the teachers? Or is this something you would hand to students as well? Because can the students just do it on their own and download Fusion 360 and just handle it on their own? Or you're really expecting someone to guide the kids through?
I think students can do this on their own as well. It's another beauty of calling it a cookbook, right? A cookbook, you can, a parent can use the contents of a cookbook or the children can use it. It's both. Okay, but I wrote the book from the point of view of a teacher because the front section of the book is all about, especially for teachers who never really played with a 3D printer, right? It explains what do you got to do. Okay, now that you've created this model, what do you have to do to, convert that file into a file that a 3D printer can read. Okay, because they're actually different files, right? There's an STL file which converts into a G-code file, and then you put the G-code file into the 3D printer. So there's a conversion process. And I mentioned in the book that, hopefully one day the 3D printing industry will fix that, right? So that conversion step doesn't need to happen at all. I mean, it could just all be done direct from, just like in a Word file, you can just print. You can just press print, go straight to the printer. But right now, it's not there yet. There's that extra step.
Yeah. I would also add that I think one of the things we tried to do with the book was really kind of combine, what is 3D printing and how to kind of design how to do 3D modeling for 3D printing. So we teach them about some of the physical limitations of 3D printing and what are the gotchas with the machines themselves. Because I think that's a lot of the kind of initial difficulty or initial kind of roadblocks to getting familiar with 3D printing is how do you get a good print? And we take teachers through that as well as actually taking them through the 3D software. So we try to marry the two together.
I'm glad you mentioned that because half the battle is just figuring out what's the best way to orient this and how do you make a model so it doesn't take forever to print? And
the great part about actually teaching this, I think, is it also, it opened up okay, we got to teach kids about gravity a little bit because things are going to droop, and things like that. I'm giving them the, what is the real world physics of something that is going to make this print work or not. So that was very cool.
Yeah, they're oftentimes the kids. Okay. This part is very interesting, I think. Okay, so humans are very used to looking at computer screens, right? And that's really kind of like, in my view, it's like 2D. And you when you create a model, you need to switch to looking at things in 3D. You really have to look at your model all around, okay? Because oftentimes you sort of default back to the 2D view, and then you create this model and you put this, for example, you put a hat on the top of a head, and then it looks like the hat is attached to the head. But then when you rotate the monitor, you realize, oh, this hat is floating in midair. So I call them floaters. And actually, this happens a lot. And I tell the kids, look, you think you finished, but look at it again. It's not finished. Your hat cannot be floating in midair. So that happens so many times.
I have like several questions in my head. I wanted to follow up with something that you said a little while ago. You said you both have kids, and I mean, you're in different locations. And you also mentioned that David in particular, you mentioned that you involve the parents and the kids together if possible. I'm curious how that has worked out, because I'm always used to hearing teachers teaching their kids, or usually the parents are just the ones who drop them off to the after school program or something.
Oh, right.
How do you get parents involved in the kids learning? And I don't know if Michael, you want to jump in if you do things differently, but David, I guess if you could start.
Well, here in Hong Kong, there are some maker spaces. And so once in a while, I will run workshops at these maker spaces that are, parent-child classes. So the parent comes in with their child and a laptop. And once they have that, I can, I can run classes like that. So the parent and the child can work together, learning the CAD, making the models, going through these models. So yeah, I've done those as well.
Are there any challenges to that?
No.
Is it any different?
It's different in the sense that you have an adult, and adults do learn a little bit faster than the children. But it's also interesting, the adults are not as creative as the children. The children, and actually, it's really true. Kids are more creative than adults.
Interesting.
So it depends on the pair. It's like some pairs, the parent is more dominant and, he'll just follow the instructions. And then other situations where the parent will just let the child take the mouse, go crazy. And yeah, you get some really interesting models from that.
That's cool. Michael, do you involve parents where you are?
And the school that I was dealing with, it was a little bit different. It was mainly an after-school program. So the kids were generally there by themselves.
Mm-hmm. Oh, you mentioned parents and children. Yes, this book is also for homeschool. And this is perfect as well. And in fact, for homeschool, now here's a special situation, right? You may not have access to a 3D printer, right?
Right.
But so what you do is you just go to Google and you type in 3D printing service in your neighborhood, right? Well, you type in the name of your neighborhood, and then you will be surprised how many 3D printers are available in your neighborhood, which you can just sort of rent out, quote unquote, rent out, right?
I wasn't aware of that. I just learned of that like relatively recently. Would you say it's as common in Hong Kong as it is here in the States?
Oh, it's very common. It's very common.
It's a great way. Like if you want to save yourself the trouble of kind of 3D printing every week, all of the models, you could just send them to a service bureau, and it works pretty well. It's all online. Just submit a file, and you get it in the mail maybe a week later or so.
Right. No, that's cool. And I also know that some public libraries have some services, but I don't know how crowded they are. Yeah. And something I saw in the introduction to one of your books, the Fusion 360 one, I don't know if it's the same in the other, but you mentioned doing groups versus individual projects. Like when you're teaching these students, Are the students going to be paired up? Are they going to be working in small groups? You make the recommendation of having them learn individually. And I'm wondering why that is.
Okay. For me, it's a function of the children's age. Because I teach as young as 8. Mm-hmm. And teamwork at that age in fact, I've tried it. It just didn't work. They just don't want to work with each other. I think, to be honest, every child probably has their own iPad or a laptop at home or some kind of Chromebook at home, and they're just used to doing things on their own at this age. And so, while I hear that, in the schools, there's a strong emphasis on group projects. No, I'm not against group projects. I'm just saying that because of such a young age and because they're only just learning the basics, right? It's okay for them to learn the basics on their own, right? Because you're just learning the basic tools at this point in time. So let them learn the tools first. And then when they get older, they can start doing projects together. In fact, actually, that's something I want to emphasize because this is this is not a STEM or a STEAM book, right? I don't cover, science or mathematics or anything like that. It's just 3D printing. So my hope is that these children learn the tools well enough so that when they do group projects at an older age, and when you do the group projects, 3D printing is only a portion of it.
Yep.
It's only a small portion of it. So when they get to that point, I want them to already know the tools that they need to make the 3D print or the 3D model for the 3D print as part of that project.
And I'm curious, Michael, if you had any thoughts on that as well.
So what I did in my classes, again, each child had their own laptop, so they were making their own model, but they were generally at tables of two. So I would try to, after the first course, I kind of figured out who was kind of a little bit better, maybe faster, at kind of getting the material, and who was maybe having problems like navigating the 3D space or something like that. And I would try to pair them together. So at least, even though they're working on individual computers, there's kind of sharing, knowledge sharing between them. So I think there are opportunities for a little bit of minor kind of teamwork, just in a kind of sharing knowledge way, I guess.
Mm-hmm.
Oh, Michael mentions something I think very important as a teacher, right? So in my class, I have 12 students. And even though I'm going through the steps of a recipe, the kids do learn at different speeds, right?
Yep.
And because they're splitting their attention between the screen in front of them and the screen the overhead projector screen, which is what they're trying to follow, there are invariably going to be some students that have missed a step, right? So for me, I've learned sort of like the hard way that it's very important to have the recipe, to give each child a copy of the recipe, right? It's just one page. And in fact, it's one of the appendices at our book, at the back of our book. If you either cut out or photocopy this page, they can follow step by step, right? So such that the kids that are slower and they get lost, they can always go back to the step, or they can say, Mr. Seto, I'm lost. And I say, okay, what step are you at? He goes, oh, I got lost at step 3. So I may be at step 4 or 5, right? So I will stop teaching. I will go to that student and I'll say, okay, let's quickly do step 3. And I can just show them right there and then how step 3, he learns step 3 and he catches up to the rest of the class, or step 4. There are some students that are very good, right? They already sort of know it. And so they can actually go to step 6 or 7, or they can actually just do the model all the way through if they want.
Mm-hmm. So you were designing it to be kind of flexible.
Yes.
You don't have to follow this recipe as if like everyone has to be on step 1 at the exact same time or whatever.
Exactly. And when I say I learned the hard way, it's because before I gave out that 1-page handouts, it was like 12 kids, 3 of them raised their hands. They go, I'm lost. Another kid says, I'm lost. And I go, what step are you on? And I go, I don't know. It's like, it's because it's not really their fault. It's because they're sort of dividing their attention between their screen, their own laptop screen and the overhead projector. So I don't totally blame them. But it is, for the teachers out there, please print out those recipes, give one to each student. It will save you that situation where you have 5 kids raising their hands and you're just running around. It just calmed the whole class significantly after I did that.
And you're both talking about the sessions that you were teaching in person. I want to go back also to the fact that this is kind of your COVID project. Have you all been teaching during this pandemic?
No, we've been writing.
And so you haven't been doing online classes, anything like that?
No, we actually, Michael and I looked into online classes, and it doesn't work the way our teaching style is, because we do need to sort of, the kids will get stuck, and we do need to take over their mouse during the class. Yeah. And there's another thing I should mention. So when at the end of the class, not at the end of the class, it's sort of like halfway through the class, I will have covered the model for the day, right? And then I say, okay, kids, you guys learn some of the tools. You can begin to make your own model. So they'll take the second half of the class to start working on their own models. Now, many of these kids actually finish their model. And at the end of the class, they'll say, Mr. Seto, I'm finished. So what I do is I will take all the models that are finished. This is after class. I will review all their models, and I will assess whether or not their models are 3D printable or not. And if they are, I put them into a queue. And this queue actually builds up over time. At the beginning, they don't produce so many models on their own, but by when the class is about halfway through or 80% of the way through, every child is making their own model. Some make 2 or 3 during class. And so what I do is I put them into a queue such that I will 3D print all their models by the next class, which is usually a week away. So that could be, usually that's like any from 30 to 35 models that I need to print in a week's time. So I sort of become like a little mini factory.
Yeah, because you got to clean them up and or are they doing that? Are they doing all the post processing?
For the post, okay. First of all, I have to make sure that I'm printing as many as I can, as quickly as I can. So I got myself a really large printer, 300 by 300 by 400, such that I can 3D print like anywhere from 10 to 12 at one time. Okay, and of course it has to work, right? Because I've had my share of experience such that, in the middle of the night, because these things will take 7 or 8 hours or even 10 hours to print. So in the middle of the night, it will just turn into a big bowl of spaghetti. Okay, and I got to do it again. But after it's all done, I do some post-processing work. I remove some of the support material, but sometimes the children tell me, Mr. Seto, why'd you remove the support materials? I said, oh, I thought I'm supposed to do that. I go, no, I want to do that. So next time, please let me do it. So I don't have to worry about that. I just give it.
Yeah, I was curious actually, like, especially when you're dealing with younger students in these in-person classes, how much are they touching and manipulating the 3D printer and, all the little parts? Is that part of the course as well, or is it mostly the software that you're focusing on in your class and in the book?
For this method of teaching, it's 99% the software.
Got it.
Because they're just too young. I don't want 8-year-olds touching the printer. I mean, especially if I need to do like 30 models a week. That's kind of a bigger risk. And the other thing is this. It goes back to the cooking analogy. These printers are just really slow. So they're just. I mean, it's like watching bread or cookies bake in the oven. It's kind of interesting for like 2 minutes, but afterwards you go, okay, what else?
Well, this is totally unrelated. I've got a side thing. I actually really find it satisfying to look at bread baking in the oven and also 3D printers running. Like I just want it, how there's TV channels where you just look at a fireplace. I just want a TV channel or a Twitch stream or something where I can see stuff being 3D printed or baking in the oven. I just really like it. So I think there's something to be said for that.
Well, you're a rational adult. These are, well, I won't say they're irrational kids, but they're kids, right? They're just jumping around all over the place.
Yeah. That said, like I think on the first class, like we make sure to have or at least I make sure to have a printer running, kind of printing a model. They can see how it works, and you let it run for a while, and eventually, like, okay, it's kind of slow.
Right. There's not that much for them to see after a little while.
Yeah. But I do agree with David. They really like taking the support material off. That's like, it's kind of like an unwrapping a present or something. It's really interesting for them.
Oh, Pius, I do need to mention one other thing. So our book has several links to the website. And one of the links is for an appendix such that it's a handout for the teachers. So in my first class, usually the kids don't know anything about 3D printing. So I need to give them like a 10-minute lecture on what exactly the technology is. So I put together a presentation. It's a keynote as well as a PowerPoint, which folks can download, that has some short videos. And actually, we're still trying to work on the bandwidth of that. It has some short videos that showcases different types of 3D printers. There's the ones that are, we commonly see in schools. These are the FDM printers. But then there are also, there's the I call them resin printers,
the
SLS printers, the laser printers, right? The metal printers. There's food printers. There's powder printers. So I want them to get a sense that, it's not just this thing that I see in front of me, which does plastic. It can do different materials. Mm-hmm. And also in the presentation, I actually mentioned there's a 3D printer at MIT that has not one extruder head. It has 11 extruder heads, and it can take 14 different materials.
Hmm.
And some of those materials can conduct electricity. And I tell them, look, you see, if you want to 3D print a robot, right, a working robot that has has electronic parts, that can has computer boards inside, etc., then this is the machine that can do it one day, right? They're still working on it. It's just a prototype, but this is the nature of the beast right now in terms of the technology, right? It's growing. It's not just these little machines that sit on your desk doing plastic. It can do so many things. So what you guys, as young students learning this modeling, it's very important because you can actually become a designer one day, right? You can make your own industrial designs, and the machines are there. It'll provide the different materials, but you just need to understand what exactly are you designing. Like you're designing a robot, right? It's got to have moving arms and legs, and it has to be able to conduct electricity. So you should know that as a designer.
Yeah. I think also an interesting thing is like they're starting to be used across different industries. And so we really try to group the models into this kind of, there's aerospace, there's robotics, there's food, there's even cosplay stuff. You can just, make models of some of the stuff your characters in a video game or something like.
That's cool. Yeah. Not to interrupt, I just wanted to say that in the preview that I had seen, I appreciate, and based on what you're saying, I appreciate that your guide or your book it's not just the tutorials. It's like you're saying, it's kind of a little bit more comprehensive to try to show kids, the context and everything related to it. And I guess before I forget, how would teachers preview your book and your materials?
Oh, they could just go to www.3dprintingcookbook.com. And there we provide an opportunity for folks to download a free excerpt, and they can check it out. The excerpt is pretty much what I shared with you, Pius, and so they can sort of get a sense of what the book would look like. So the book is available on Amazon on June 18th. Actually, the two books. So please please go to the website 3dprintingcookbook.com and see which one is suitable for you. So once again, the Tinkercad one is for kids age 8 to 11, and the Fusion is for kids age 11 or older or adults. And if adults want to give this a try, you can try both. I mean, it's they're people friendly, I would say.
Yeah, I would add also, even if you're not a teacher and you're just interested in 3D printing or trying it out, the excerpts are a great way to kind of get started and try out something in a very simple way. So, yeah.
Yeah, there are plenty of non-educators who listen too, just maybe business people like yourselves and people doing other things and hobbyists. So they should all check it out. I know Michael and David, you were working together on this. Did you all have specialties in creating this book? Like, what did you all do in this project?
Well, basically, I did the text part and Michael did the layout. And the layout is super important for a cookbook. It's actually very important for a cookbook.
Yeah.
So I had a history in graphic design and other kinds of design, so it was kind of a natural that I worked on that part. So I just tried to make it as friendly and something you could just kind of open up on your desk and have both pages open without the book trying to close up on itself or anything,
Right. Actually, that kind of makes sense because I guess you said earlier that you have a background in game design. I'm curious if this book has any comparisons to game manuals or something like that.
Yeah, I would say it's more like a cookbook, in that sense.
Okay.
Like, I modeled it after like an old Betty Crocker cookbook, to be honest.
Oh, wow.
Updated a little bit. But the idea of being something you can kind of sit beside your tools or beside your workspace, and you can kind of just look at it very easily, big text, and just follow along. Very approachable, not like a textbook, not like a O'Reilly book or anything, but something that's like super easy, gives teachers confidence that they can do it. Because I think a lot of books out there, they just get technical really quick, and I think sometimes that might turn people off.
Yeah, the worst would be if it's just a wall of text and like screenshots. It's not the best, but this is not that. Also, this is kind of unrelated, but you all said that you had been in China and Hong Kong. I'm always curious how STEM education, engineering education, how it compares in different places, because I have my American bubble, my Texas bubble.
Sure.
How would you say the enthusiasm for engineering education, STEM education, and 3D printing, how would that compare in China and Hong Kong compared to the USA?
Yeah, I can actually I can speak to that. Actually, I'm originally from Oklahoma, so I have a little bit of that Texas bubble. But so I would say that like in China, at least, it seems to me that there's definitely more emphasis placed on education in general, and there's also more kind of engineering, math. It's a good pursuit. Such to the fact that when my daughter moved back, she was in third grade. She was so far ahead of everybody. She felt really great. But then after 2 years or so in the United States, I think she kind of slowed down a little bit, and she got some of that social pressure about how math and science is not so cool.
How old was she at that time, if you don't mind me asking?
Yeah, she was in third grade, so that was about 8 or 9, something like that. Yeah, so as she got older, she started hanging out with more friends, more social culture, more pop culture, and I think there's something in the pop culture that tries to paint science maybe as not so hot, in kids' lives, and I don't think that's a good thing. I was lucky; I had a really great physics teacher back in high school, and he was like really transformational. I mean, he was great. Yeah, Brad Browser. He was good. He was former DOE guy, but he treated kids with respect, and he was open to everybody, and he made things simple. So, yeah.
And I had heard from other people the reputation of education in Beijing and then other parts of China. I don't know if can it go too far, like the emphasis on STEM education or just education in China? Is that not a fair judgment?
I mean, I think it is, but I think modern parents, they also, they know what the kids are going through to some extent, right? They've been through it before. I think they also start to understand the importance of this kind of well-roundedness a little bit more. It doesn't mean there's not a lot of classes, but the classes are maybe more diversified. So, you have some sport, you have some music, you have some, academic stuff, right? and then also getting kids out to have experiences, like in the real world, like trips and things like that.
And this is China you're talking about?
I'm talking about China. I'm not talking about Hong Kong. Yeah. But David can talk about Hong Kong.
Yeah, David.
Well, yeah. So I don't know if your listeners know, Hong Kong is a kind of like a metropolitan city, population of about 7.5 million people. So compared to China, we're just like a drop in a bucket. But it's a pretty comfortable city to live in now. So after decades of growth, economic growth, and everything, so I read not too long ago, Hong Kong sort of has a standard of living similar to like a Canada. So for those people who know Canada, Hong Kong is sort of like that. It's not a bad place to live. It's pretty safe. Public transport is super clean and very efficient. The government is very well aware of STEM education. They've allocated money to all the public schools for STEM education. And so one of the first things they buy is a 3D printer. And so this actually another reason why I think our cookbook should be okay, because it's exactly what Michael was describing. Yes, they have the government funding to buy a 3D printer, but that printer is most likely just sitting in the corner collecting dust. And yeah, so that's what we're trying to do. It could really also goes back to saving time. I mean, the teachers here in Hong Kong, they're already overwhelmed by you have all these exams they got to prepare the children for. They just asking them to learn CAD is like it's too much.
Yep. So it's actually really similar, it sounds, to the pressures in the U.S., pressures on teachers and education in the U.S.
Yeah, it is very similar. Very similar.
Thanks so much for answering all my questions so far. I know you mentioned where to find more information about your new book. Last question, though, do you have any plans for the future, whether it's with this book or if you're going to be teaching in person again, and where people could find you if they wanted to experience your classes?
I'll go ahead. So actually, another one of my projects is this kind of personal knowledge management system kind of thing that I'm working on. So I kind of want to kind of pursue that after this. Kind of make all your notes and stuff easier to kind of bring together in your head, basically.
Cool.
Yeah, for me, we're going to focus on marketing the book for a while, at least for myself. And now we say in the book that, sometimes these softwares get updated every once in a while. So maybe in 2 or 3 years, we need to come back and do a new edition with new screenshots. But other than that, Pius, you told me beforehand that you teach math, right?
That's correct.
Yeah. So also during my COVID time, I took online classes for calculus. Now,
oh, wow.
I told you all, I come from a finance background, a business background. So I know nothing about engineering. So I went through 3 courses in calculus, college level. I'm starting to learn physics next.
Hey, congratulations. That's intense.
Yeah, it's crazy intense. It's because we just stuck at home. What are you going to do? You just got to do something.
Wow.
And also I did some volunteer work. So here in Hong Kong, there's a group of, there's an organization that is trying to encourage young people to look into outer space as a career path. And one of the key features of that is 3D printing. So one of the courses that they're trying to look into is to see if we can get some kids in Hong Kong to build their own CubeSats. So CubeSats, I don't know if you know or not know, but they're these little 10 by 10 by 10 cm boxes that have electronics in them. So, something basic is like, it's got to be able to take a picture, right? So you put your camera inside the CubeSat, right? You launch it into orbit, and then while it's in orbit, it has to take some pictures, and it sends the data back down to Earth to your laptop. Now, that CubeSat has electronic components as well as the outer casing, which can be 3D printed. So this is sort of like my next evolution as an explorer in this tech space, because I don't have the engineering background, which is I want to take the next step, which is to go see how I can get into electronics, learn the physics, explore outer space, and see where that can take me.
That's awesome. And then you can write a book about it so teachers can follow your lead.
Maybe. We'll see.
So David Seto, Michael Welch, thank you so much for joining me on the podcast. I hope that more people check out your new project and your new book.
Thank you for giving us this opportunity to tell everybody about it.
Thanks a lot, Pius.
That was David Seto and Michael Welch, authors of the 3D Printing Cookbook. To find links to the books, Tinkercad or Fusion 360 editions, look in the show notes for this episode. You can also find links to the books and other topics mentioned today at the show website, k12engineering.net. The K-12 Engineering Education Podcast is sponsored by my creative studio, Pios Labs, in Austin, Texas, where I consult on engineering and education, making podcasts, programming educational technology, training professionals, and more. Follow Pios Labs all over the internet to stay updated. That's PIOSLABS. This podcast is possible thanks to amazing people passionate about education and engineering who donate to the show to help me pay for streaming services, equipment, and all around just keeping it up. You can donate too on Patreon. Just go to patreon.com/PiosLabs. Also, you can help the show by giving it 5 stars on Apple Podcasts, Spotify, or whatever platform you're listening to it on. That helps get more people listening to these STEM education issues. So, listener, thank you, and until next time.